MAP4C 5.3 Linear Models. Tables, graphs, and equations are examples of mathematical models. A linear model represents quantities that increase or decrease by a constant amount over equal intervals. Starting off with a table of values. If the first differences are constant, then the table represents a linear relation. Otherwise, if the first differences are not constant, we can say that the table represents a nonlinear relation, meaning that it is not a line or a constant rate of change. So for example, which model represents linear relations? Justify your answers. So if you're just given a set of values in a table, then what we need to do is look at these ordered pairs. Do we have equal intervals for our time? If we do, then we can look at just the first differences of our y variable. So the first differences are achieved by doing the second point minus the first point. So compare the difference between adjacent points. 55 minus 60 is negative 5. 40 minus 55 is negative 15. And 15 minus 40 is negative 25. So the first differences are not constant. Constant means that they are the same value. So we can say that this is a nonlinear relationship. The first differences are not equal. The relationship is nonlinear. Next, B. So we're comparing hours and earnings. We see that our hours are at equal intervals spaced by 5 units, and that our earnings will compare our first differences. 40 minus 0 is 40, 80 minus 40 is also 40, and 120 minus 80 is also 40. So, if we know that our first differences are all equal, we can say that this is a linear relationship. Next, graphs of linear relations. The vertical inset represents the initial value of the dependent variable. The dependent variable is y, and if you remember our sentence for understanding which axis is which, y depends on x if there's a causal relationship. The slope represents the rate of change of the dependent variable with respect to the independent variable. So y depends on x, and we're looking at here the difference in height, which is the rise divided by the run. If this is constant, like you see here, I'm not going to reveal it. Which of the graphs are linear relations? And by inspection, can you tell me which of these is linear? And these are all constant. That's a visual representation of an equal rise over run for each of these intervals. And we could take any two instances, and when we divide the rise over run, the ratio would be equal. Notice in this case here, braking distance and speed, the relationship of the height to the run, so rise to run, changes on this graph. It's not a line. So we say that it's nonlinear. A linear relationship is a straight line. In a linear relation, m is equal to rise over run is constant. So this is easy to determine by inspection, just looking for if the graph is a line, it's linear. A bit more challenging is to identify linear equations. A linear equation is a degree 1 polynomial, and the degree of an expression is the highest exponent on the variable x. So in this case, this is our variable x, and if no exponent is written, we assume that it's the value 1. So we can call this a degree 1 polynomial because the one variable, remember that a variable means that this can take on any value, and it's a relationship between the variables x and y. So we can substitute in different values of our independent variable x to get an output for our dependent variable y, where m is the rate of change. M is the slope, but we're interpreting it as the rate of change between two variables, and b is the y-intercept. So where does it cross? The line cross the y-axis. Looking at these equations, which equation represents a linear equation? So our first example, A, y is equal to 2x plus 5, this variable x, notice that these constants have a value that will always be the same. But our variable has an exponent of 1, meaning it's a degree 1 polynomial and it's linear. In our second equation, notice that for our variable x, the exponent is 2. This is a degree 2 polynomial, and therefore it's nonlinear. A degree 2 polynomial is a quadratic relationship. Good luck.